In the folded darkness between stars, where light forgets its way home, something breathes backward. Not breathing as lungs know it, but a drawing in that never releases. A gravity so complete that time itself bends double, curves until past and future trade places in the silent architecture of space. Black holes rest in that impossible geometry, patient as stones at the bottom of an ocean that has no surface. They do not announce themselves with fire or sound. They simply are. Absences so dense they remake the meaning of presence. Perhaps the universe, in its oldest corners, learns to dream by unmaking. Perhaps these wells of collapsed starlight are where causality goes to remember itself differently, where every photon that falls inward writes its story in reverse, across an event horizon no eye will ever see. The cosmos builds, and the cosmos dismantles, and somewhere in that rhythm, construction, collapse, construction, collapse, a kind of sleep may settle over the architecture of everything. 400 billion galaxies, each one a city of suns, and scattered among them, these apertures into elsewhere. Not holes at all, but thresholds. Not empty, but so full of mass that matter forgets how to be matter anymore. Light approaches, bends, spirals, crosses a boundary that has no thickness but infinite consequence. And everything that passes through becomes a sentence written backward in a language only gravity can read. If dreaming is the mind's way of reorganizing daylight into strange new geometries, then perhaps black holes are the universe's way of reorganizing starlight into geometries stranger still. A dream where time runs the wrong direction, where cause follows effect like a shadow walking ahead of its body, where the last thing becomes the first thing, and the first thing dissolves into a point smaller than thought. The question hovers. The darkness listens. Everything waits. Most astronomers agree that black holes form when massive stars exhaust their fuel and collapse under their own gravity. The process unfolds across millions of years of burning, then completes in seconds. A stellar core condensing past the point where atomic forces can resist, crushing down through densities that empty words like heavy of all meaning. What remains is a singularity, a point of infinite density surrounded by an event horizon, that invisible boundary where the escape velocity exceeds the speed of light. Evidence suggests that space around a black hole warps dramatically. Einstein's equations predicted this nearly a century ago, not as metaphor, but as literal curvature of space-time itself. Massive objects bend the fabric of the cosmos the way a stone bends the surface of a trampoline, and black holes bend it until the fabric folds back on itself. Light from distant stars arcs around these wells, creating rings of distorted illumination called Einstein rings, halos of borrowed brightness around the dark. Scientists believe that once matter crosses the event horizon, it can never return to the universe we inhabit. Information falls in and, according to classical physics, disappears forever. Yet, quantum mechanics whispers otherwise. That information must be conserved, that nothing truly vanishes, even in the universe's deepest wells. The paradox remains unresolved, a quiet tension between two frameworks we use to understand reality. The event horizon keeps its secrets. The singularity does not reply to our equations. Roughly 4.5 billion years ago, when Earth was still cooling from its violent birth, black holes were already ancient. Some were born in the first generations of stars, less than 1 billion years after the Big Bang, when the universe was hotter and more densely packed with light. These early giants consumed matter voraciously, growing into the supermassive black holes now found at the centers of most galaxies, including our own. Sagittarius A, nestled at the Milky Way's heart, holds the mass of 4 million suns compressed into a region smaller than Mercury's orbit. Through long seasons, galaxies evolved around these central anchors. Stars formed in great spiraling arms, lived their billion-year lives, and died. Some quietly as white dwarfs, others explosively as supernovae, and some, the truly massive ones, collapsing into darkness that would never release them. Over ages, the populations of black holes grew. Stellar mass black holes scattered throughout galaxies, supermassive ones holding court at galactic centers, and perhaps intermediate mass black holes in the dense star clusters where smaller holes merged and grew. Observations made in the last few decades have allowed scientists to detect black holes indirectly through their effects on nearby matter. When a black hole orbits a companion star, it pulls material from that star in long streams that spiral inward, heating to millions of degrees and emitting X-rays before vanishing forever across the event horizon. These X-ray binaries flash in space like distant lighthouses, marking the locations of invisible giants by the way they feed. In 2019, an array of radio telescopes spread across the Earth worked together to capture the first direct image of a black hole's shadow, the dark circle at the center of the galaxy M87, surrounded by a ring of glowing plasma. The image confirmed decades of theory. Black holes cast shadows. Against the light, they bend around themselves. Meanwhile, gravitational wave detectors have begun listening to the ripples in space-time, caused when black holes collide and merge, sending shudders across hundreds of millions of light years. The universe rings like a bell when its densest objects meet. As the centuries drifted, physicists refined their understanding of what happens near these boundaries between ordinary space and radical curvature. Time dilation becomes extreme. An astronaut falling toward a black hole would appear, to a distant observer, to slow down. As they approached the event horizon, their image reddening and dimming until they seemed to freeze at the boundary forever. But from the falling astronaut's perspective, nothing special marks the moment of crossing. They pass through the horizon in finite time and continue falling toward the singularity, where all equations break and physics itself loses coherence. Some researchers propose that black holes are not entirely black, that they emit faint thermal radiation through quantum effects at the event horizon, a phenomenon Stephen Hawking described in the 1970s. This Hawking radiation suggests that black holes very slowly evaporate over timescales vastly longer than the current age of the universe. A stellar mass black hole would take 10^67 years to evaporate completely, an expanse of time that makes the age of stars seem like a single breath. The radiation carries energy away, and over eons unimaginable, even these seemingly eternal objects will fade. Yet beneath that stillness, beneath the equations and observations, a question remains just beyond the data's edge. What is it like inside? Not for matter, which is destroyed, but for information, which quantum theory insists must persist somehow. Where does the light go? Where does time go? The record ends at the event horizon. The mystery begins. Beyond what telescopes can see or mathematics can predict with certainty, imagination finds room to breathe. And in that breathing space between known and unknown, a strange thought emerges. Perhaps black holes are not merely the universe's graves, but its deepest contemplation. Perhaps they are the cosmos turned inward, examining its own nature through the lens of ultimate compression, taking all the complexity of stars and light and chemistry and reducing it to pure geometry, pure curvature, pure potentiality. Some theoretical physicists have proposed that black holes might be related to the universe's fundamental information structure. If information is never destroyed, then perhaps what falls into a black hole is not lost, but encoded somehow on the event horizon itself, written into the quantum structure of that two-dimensional surface. This holographic principle suggests the three-dimensional volume of a black hole might be completely described by information on its boundary, as if everything inside is a projection from a cosmic screen, the universe folding itself into flatness, writing its depth as surface. Others wonder whether black holes could be connected to regions beyond our observable universe. Some solutions to Einstein's equations allow for bridges through space-time, wormholes linking distant regions or even separate universes altogether. While most physicists believe these bridges would collapse too quickly to allow passage, The mathematics permits their existence under certain exotic conditions. Perhaps black holes are doorways, not endings. Perhaps what falls in emerges elsewhere, translated into a new vocabulary of matter and energy that no longer resembles what it was. The reversal theme deepens here. In our ordinary experience, entropy increases, disorder spreads, heat dissipates, complexity decays into simplicity. Time flows from past to future like water running downhill. But at the singularity of a black hole, where time and space trade places mathematically, where the radial coordinate becomes time-like and time itself becomes a spatial direction, perhaps entropy behaves differently. Perhaps the arrow of time, that fundamental asymmetry that distinguishes memory from prediction, flips direction. Not literally, but in some deep structural sense that our equations can hint at but never quite grasp. Evidence suggests that black holes have entropy proportional to the area of their event horizons, not their volume, another strange inversion of expectations. The second law of thermodynamics still holds, but in a way that makes black holes the most entropic objects in the universe per unit volume. They are disorder incarnate, chaos compressed, the endpoint of every process that shuffles and mixes and increases randomness. Yet from outside, they appear perfectly simple, defined entirely by mass, spin, and electric charge, all other information erased. This is where science encounters its own event horizon, where metaphor becomes necessary because the literal description falls short. If black holes are the universe's way of processing information, compressing complexity down to fundamental parameters, then perhaps they function like cosmic forgetting, not as tragedy, but as necessity. The way a mind must forget most of each day to function, must compress 1,000 sensations into a single memory, must simplify the overwhelming particularity of experience into usable patterns. Perhaps the Earth was remembering itself this way 4 billion years ago, sorting stone from metal, atmosphere from ocean, complexity from chaos. And meanwhile, in the vastness beyond, black holes were performing their own sorting, their own compression, their own distillation of what matters from what can be released. Not consciously, there is no suggestion of awareness in these massive objects, but functionally, operationally, the way a river carves a canyon without intending to, simply by following the gradient of gravity. Yet beneath that mechanism lies a pattern that whispers of something deeper. Dreams operate by reversal too, by taking the day's experiences and running them through strange transformations, recombining elements in unexpected ways, playing time backward and forward simultaneously, dissolving cause and effect into surreal narratives that somehow, mysteriously, help the mind process and integrate what consciousness cannot handle directly. In dreams, the dead return to life. Impossible spaces fold into themselves. Years pass in seconds. Past and future coexist in single images. It may be more honest to imagine than to claim, to wonder whether the universe in its black holes is doing something analogous, not dreaming as minds dream, but performing some vast informational operation that resembles dreaming's recursive, self-referential nature, taking the universe as it is and processing it into something else, something compressed and encoded and transformed, running the movie backward to see what patterns emerge, unmaking creation to understand creation better. Some studies propose that the Big Bang itself might be connected to black hole physics, that our entire universe could be the interior of a black hole in a larger space-time structure. The math permits this idea, though evidence remains speculative. If true, then we are already living inside a cosmic dream, a space where time began at a singularity and flows outward into increasing complexity. And the black holes we observe might be smaller versions of the same process, nested dreams within dreams, singularities within singularity. As the mind descends into sleep, consciousness doesn't vanish, it transforms. The waking world's logic loosens, time becomes flexible. Separate memories merge and separate again. The boundary between self and world softens until you are simultaneously the dreamer and the dream, the observer and the observed, the question and the answer coexisting without contradiction. Perhaps black holes exist in that same liminal space, physically embodying paradoxes that our waking physics cannot resolve. Information both preserved and destroyed, time both flowing and static, endings that are also beginnings. In the quiet between epochs, when stars have burned down to embers and new ones have not yet ignited, when galaxies drift apart in the universe's ongoing expansion, black holes will remain, patient, silent, still gathering whatever matter wanders too close. Over timescales longer than thought can comfortably hold, they will evaporate through quantum tunneling, radiating their mass away in whispers of heat until even these most permanent-seeming objects fade to nothing, the universe forgetting its own depths, the dream dissolving back into the dreamer. And yet perhaps, in that final evaporation, in the last quantum of Hawking radiation, escaping from the last black hole in a cold and empty cosmos, some information about all that ever fell in persists. Perhaps the universe's memory survives in encoded form, written into the fabric of space-time itself, like scars that testify to old wounds healed. Perhaps nothing is ever truly lost, only transformed beyond recognition, translated into a language we have not yet learned to read. The equations remain unsolved. The paradox stays beautiful. The universe continues its own contemplation, and we watch from our brief moment of warmth and light, guessing at meanings in the pattern of shadows. Time exhales. When stone forgets its shape, does it still remember heat? When light falls into darkness, does it carry the memory of stars? These questions have no answers in the language of measurement, only in the language of wonder. Black holes concentrate the universe's most profound mysteries into spaces smaller than atoms, yet their effects ripple outward across galactic scales, shaping the distribution of matter and energy in ways we're only beginning to understand. We are made of stardust, every atom in our bodies forged in the nuclear furnaces of ancient suns, or in the violent collisions that followed their deaths. The calcium in our bones, the iron in our blood, the oxygen we breathe, all synthesized in stellar cores and scattered across space when those stars exhausted their fuel. Some portion of that matter may have, in the deep past, orbited near a black hole before being flung back into space. Some of the carbon that forms our molecules might have spiraled in an accretion disk, heating to millions of degrees before escaping by chance, carrying with it information about that close encounter with the universe's most extreme environment. Our own existence is an echo of cosmic processes we can barely fathom. We live on a planet circling a star in a galaxy with a supermassive black hole at its center, safe enough in our outer arm position, but still gravitationally bound to that massive anchor. Every thought we think, every memory we form, every dream we dream at night, all of it occurs within the gravitational influence of Sagittarius AO. Though so distant and so weak at our location that we never notice. The universe dreaming within the universe dreaming. There is humility in this recognition that the human scale, vast as it seems to us, occupies only the narrowest band in the spectrum of cosmic possibilities. Smaller than stars, larger than atoms, we exist in that middle realm where chemistry permits complexity, where gravity is gentle enough to allow structure, where time flows at a pace that allows for growth and change and memory. Black holes occupy a different realm entirely, where those comforting middle conditions break down and physics becomes strange. Yet we can still contemplate them. Minds made of atoms can think about singularities. Beings whose lives span decades can reason about processes spanning eons. Creatures bound to a single planet can imagine what happens at event horizons we will never see. Perhaps this capacity for imagination, for reaching beyond immediate experience into realms we can never directly visit, is itself a kind of reverse dreaming. The mind projecting outward instead of inward, exploring external mysteries instead of internal ones, but using the same fundamental tool, the ability to construct mental models of things that are not present. Oceans rose on the early Earth, continents wandered across the mantle, life emerged and diversified and learned to look upward at the night sky. And all the while, black holes continued their patient work of bending space, consuming matter, storing information in forms we cannot access. The story of the universe unfolds in parallel layers, the story of matter organizing into complexity, and the story of matter collapsing into singularity. Creation and dissolution, waking and sleeping, holding the same threads in different hands. When we sleep, the brain performs vital maintenance, consolidating memories, clearing metabolic waste, reorganizing neural connections to prepare for the next day's challenges. Sleep is not absence, but transformation, not emptiness, but hidden activity. Perhaps black holes serve some analogous function for the cosmos. Not conscious, not purposeful, but necessary nonetheless. Places where the universe can set aside what it no longer needs in its current form, compressing old information to make room for new structures, recycling the very fabric of space-time itself. The comparison stretches, becomes tenuous, threatens to break under the weight of too much metaphor. But the feeling it evokes remains valid, that black holes are not enemies of order, but part of the cosmic ecology, necessary participants in the great cycle of stellar birth and death, structure and dissolution, information and entropy. They are the punctuation marks in the universe's long sentences, the pauses between verses, the silence that gives meaning to sound. In the end, we can only witness from our distance, bringing our human capacity for wonder to bear on phenomena that exceed human scale, by factors so large the numbers lose meaning. We can measure, theorize, observe, imagine, but we cannot know directly what the universe experiences in its deepest wells. We can only note the pattern. That reality seems to require both expansion and compression, both creation and destruction, both waking and sleeping. And perhaps that is enough. Perhaps the gift is not in solving the mystery, but in living within it. Conscious beings briefly aware of the vast, unconscious processes that gave rise to consciousness itself. Brief sparks of warmth in a cold universe, brief moments of thought in cosmic spans of silence, brief questions asked in the face of enduring mystery. The light still bends. Dusk settles over the ledger of stone, the record of everything that has fallen and everything that endures. In the beginning there was light, or so we imagine, a hot, dense state, expanding into structure, cooling into matter, matter clumping into stars. Some of those stars burning still, some already collapsed into darkness that remembers light the way memory remembers a dream. Black holes rest now in their scattered positions across hundreds of billions of galaxies, silent sentinels at the centers of spiral arms and elliptical clouds, stellar remnants drifting through interstellar space, supermassive anchors holding galactic cores in their invisible grip. Nothing moves them easily, nothing hurries them. They wait with the patience of things that have already forgotten hurry, already forgotten time as we measure it. The universe continues its slow expansion, galaxies drifting apart, stars consuming their fuel and dying. Over timescales we can barely name, even black holes will evaporate, not suddenly but quantum by quantum, radiating away their mass until even these most permanent seeming structures dissolve into the background hum of space. The universe forgetting its densest dreams, the cosmos releasing what it held most tightly. But that ending lies so far in the future that the present still seems eternal. For now, the black holes keep their vigil, and the stars still burn, and consciousness still emerges on scattered worlds to look outward and wonder. The question remains unanswered because perhaps it was never meant to be answered. Perhaps it was only meant to be asked again and again in each generation that learns to see beyond its immediate horizons. In the dark salt of the cosmic ocean, where waves of probability ripple across the substrate of space-time, where particles wink in and out of existence like thoughts on the edge of sleep, the black holes continue their work of compression and storage. Not storage as computers store data, but as the Earth stores memory in its layers of sediment, as DNA stores information in its sequences, as the pattern of stars stores the history of nucleosynthesis in their spectra. Everything that falls in carries with it information about what it was. A star's life history encoded in its spectrum, a planet's chemistry written in its elements, the traces of 1 billion years of cosmic evolution compressed into the singularity's timeless point. And perhaps, in some way we do not yet understand, that information persists, not as recoverable data, but as subtle influences on spacetime's structure, as perturbations in quantum fields, as echoes too faint to hear directly but present nonetheless in the universe's mathematical architecture. The night deepens, temperature falls, the listener's breath slows to match the rhythm of words descending into quiet. This is where knowledge gives way to acceptance, where questions dissolve into the comfortable darkness of not knowing, where certainty becomes less important than the gentle recognition that mystery is not a problem to solve, but a space to rest within. Black holes are the universe dreaming in reverse, or they are not. They are cosmic information processors, or they are simply massive objects following gravity's rules. They preserve everything that falls into them, or they destroy it beyond recovery. The truth may be all of these or none, some synthesis we cannot yet imagine, some framework that reconciles contradictions we currently see as irreconcilable. What matters, here at the edge of sleep, is not the answer, but the question's shape. The way it opens space for wonder. The way it suggests that even the universe's darkest, densest, most extreme phenomena might participate in patterns we recognize from our own experience of consciousness. The patterns of memory and forgetting, of transformation and preservation, of time running forward and dreams running backward, of holding and releasing. And the earth keeps breathing. Oceans rising and falling with tides pulled by the moon's gravity, the same gravity that on larger scales creates black holes. Mountains slowly rising and eroding, the same processes of accumulation and dissolution playing out in rock and water and time. Stars still burning overhead, their light traveling years or centuries or millennia to reach our eyes, carrying information about nuclear reactions happening in real time in realms we will never visit. So do we breathe, in and out, consciousness rising into waking and descending into sleep, thoughts organizing and dissolving, the brain performing its nightly work of sorting, storing, releasing. The same fundamental patterns at every scale: creation and destruction, structure and entropy, questions and silence. The universe folds into itself, time bends, light falls forever across a boundary that has no thickness. Information compresses down to pure geometry. And somewhere in that compression, in that bending, in that eternal fall, perhaps meaning emerges not despite the paradox, but because of it. Perhaps we were never meant to understand completely. Perhaps the gift is the wondering itself, the reaching toward comprehension across gulfs of space and time that dwarf our brief existence. The black holes keep their secrets. The equations remain beautiful. The stars still shine in the darkness between. Everything dreams. Everything waits. The light fades.